Hi, hello everybody. So this is the video dealing with section 4.4, trigonometric functions of an angle. So this is the first part where we're going to first review the basic trig functions and kind of remind you a little bit what the basic definitions are and the type of problems that we saw in the previous section. In addition, we're going to add one minor variant to the problems from section 4.3. Okay, so in 4.3, we've covered the basic definitions of trig functions of an angle, and um, mainly in that particular section, we've covered, here's the picture. We've covered the definition on the movement on a circle, you remember, right? Particle is moving on a circle, and the movement forms a triangle. So here's a triangle here. In the previous section, we've covered specifically one movement on the circle where the radius was 1. So that's why we called it the unit circle. Okay, unit because of radius 1. Now we make the definitions a little bit more general. And as you can see here, the radius can be anything that is a positive value. So the movement's still going on. So we're going into this direction. Every time it forms a point along this circle of radius r, and we have a segment y and we have a segment x. The six definitions are here. Whereas before, sine of theta or t was just y, because the radius was 1, now is y over r because the radius may be something else. Cosine is x over r. Tangent, as we've seen before, is sine of theta over cosine of theta. And so it's y over r over x over r. So if we multiply by the reciprocal, obviously we get r over x. The r's cancel and I get y over x, provided that obviously x is not 0. The other three functions are their reciprocals. So cosecant is 1 over sine, so it's r over y. Secant is 1 over cosine, so r over x. And cotangent is 1 over tangent, or x over y, provided obviously that each denominator is not 0. So these are the definitions, and this in this instance, since the circle is no longer a unit circle of radius 1, we do have to divide by r because r is not going to be 1 necessarily. Okay, so this is the type of problem that we've seen before, and this is a little bit of a variant because, like I said before, the radius is no longer 1. Okay, so let's take a look at example 1. Same type of problem. Here's a point, and I am given the terminal side of theta, and we're supposed to find the other 6 trig functions. Okay, here's my point. This is the angle theta, and this is a radius r that is not 1. Now here's our triangle. All right. And what we need to find is the 6 trig functions. Well, it's very easy, right? So sine of theta is the y segment. Here is the y segment over the radius. The problem is I don't know what the radius is yet. So even before we do any of that, I have to find this length, which is the radius. But we know how to do that. If this is 3 and this is 5, right? Because this is x and this is y. Well, professor, but it's negative. Yes, I know it's negative because the point is in the third quadrant, but this segment is positive 5. This segment is positive 3. And I can certainly find the radius using the Pythagorean theorem. So r squared equals 3 squared plus 5 squared. So 9 plus 25. And we get 34. Obviously, we take the square root of both sides. And we get square root of 34. Now, if we were able to, we would simplify this thing, but it's just 17 times 2. And we cannot do anything with that. So the radius is 34. So sine of theta is y over radius. The y is 5. Okay. And the radius is radical 34. Now, we can't leave it this way. We have to rationalize. So you know how to rationalize. Multiply by radical 34. And radical 34, radical 34. So this is 5 radical 34 over 34. Now, however, we'll discuss this briefly because the point is right here, and right here, sine, which is this axis, is negative. Okay, this answer is negative. So this is very important. Cosine theta. Cosine theta x over r. I know what x is. It's 3. Okay. This segment is 3. R is radical 34. So same as before. Multiply by radical 34. So 3 radical 34 over 34. And again, because cosine in the third quadrant is negative, this is the axis for cosine. Here's negative. This answer is negative. Okay. Tangent. Tangent, I can divide sine over cosine. Or as we've mentioned in the definition, y over x. So I can do y over x. And tangent on the third quadrant is positive because both sine and cosine are negative. So it's going to be negative 5, right? Negative 3. And then we can find the reciprocals. So cosecant is 1 over sine. Okay. And instead of using this final expression, because if I do, I'm going to have to rationalize it again, I'm going to use this one. So it's 1 over that. 1 over 5 over radical 34, which is obviously radical 34 over 5. Okay, but keep in mind, minus. Secant, 1 over cosine, and I'm going to use this expression again. Radical 34 over 3, and obviously minus. Why is it minus? Because it's 1 over cosine, and cosine is negative. Cotangent is 1 over tangent, and it's positive, so it's 1 over 5 over 3, which is 3 over 5. Let's just multiply by the reciprocal. You know how to do this. I'm not doing it here because I am assuming you know what to do. So keep the first fraction as is and invert the second one. So 3 over 5. Okay. So we have the 6 trig functions, but we needed to be aware of the negative and or positive signs. Okay. So the y-axis is sine of whatever angle theta t, and cosine is the x-axis. So this axis right here is cosine. Okay. Now, we do need to know, we need to find a way to know or memorize, which quadrants sine, cosine, and the other four functions are positive or negative. Now, this is very easy. We only need to know the first two. We only need to know sine and cosine because we can find the other ones by definition. Now, again, sine of theta t x, whatever you're dealing with, whatever angle, and this is cosine. So imagine you have a point here, xy. Again, y is sine, x is cosine. In the first quadrant, sine theta, cosine theta are positive. I don't need to memorize that the other ones are positive, even though they are. Okay? If I know sine and cosine, then I can find tangent by divide one by the other. I can find cosecant by doing 1 over sine, and I can find secant, which is 1 over cosine. So if sine and cosine are positive, tangent is positive, cosecant is positive, and secant is positive. I don't have to memorize the other four. Now, the same applies for the second quadrant, third, and fourth. Okay, I'm just going to do one. So we already discussed maybe quadrant three. Let's take a look at quadrant two. So here's my point. Okay, in here, y is positive. The y coordinate is positive because it's above the x-axis. X is negative. Now, what does that mean? It means that sine of theta is positive, sine of theta is negative. Okay, let me just show you what's written here. Sine and cosecant, I don't need to memorize this. I just need to know this based on the point. Now, so if sine is positive, then that means that cosecant is positive because cosecant is 1 over sine. If cosine is negative, that means that secant is negative. And I know that tangent is sine over cosine, so positive sine, negative cosine, tangent has to be negative, which means what? That cotangent is also negative. All right, so you can do the same thing on quadrant three and quadrant four. Let's just take a look at quadrant four real quick. I'm not doing quadrant three because we've done it in the previous example. Let's say I have a point right here, xy. In here, the x coordinate is positive, y coordinate is negative. Now, what does that mean? Okay. If x is positive, cosine of theta is positive. If y is negative, that means the sine of theta is negative. And then sine divided by cosine tangent, tangent of theta is negative. Once I have the basic three, I will find their reciprocals. Cosine secant theta greater than 0 because it's the reciprocal. Sine negative, cosecant negative. Tangent negative, cotangent negative. Okay, so it's very easy to just derive them from the basic two, sine and cosine, and then derive tangent, secant, cosecant, and cotangent. So we don't have to memorize this table, but if you do want to memorize it, you are absolutely allowed to do so. Now, let's see an example that involves these concepts of positive and negative trig functions. So here's a typical question. If tangent is negative and cosine is positive, which quadrant is theta? Okay, so let's take a look. So here is, I don't really have to draw a circle, maybe just the axis. And I am going to write that y here is my sine of theta, and that x here is my cosine of theta. All right. So if I have the cosine, here I am. If I have the cosine is positive here or here. I'm either on the first quadrant or the second. Now, where is sine negative? Sine here is positive and positive. Sine is negative here and here. So the only quadrant where uh, I'm sorry, I was looking at the other one. So we're doing example 3. The only location where tangent is negative is when cosine is positive. So keep in mind, tangent theta, sine theta, cosine theta. If cosine is already positive, the only way for tangent to be negative is if sine is negative. Okay? So I know that cosine is positive. So I am either first quadrant or fourth. Now I also know that sine has to be negative. Well, the only way that sine is negative is if I'm either here or here, third and fourth. The only location where both coincide is quadrant 4. Quadrant 4. And you can do something very easy to check this. I'm not going to do it now, but you can do the following thing to check. If you don't know how to do what I just did, you can do the following. Pick an angle in the fourth quadrant. What's an angle in the fourth quadrant? This angle right here. And let's say theta equals 300 degrees. It's in the fourth quadrant, right? It's in Q4. Now, confirm that this is correct. Use a calculator and then find tangent of 300, and you're going to see this is going to be negative. And find cosine of 300, and you're going to see that that will be positive. And that's a confirmation that the only situation where you have tangent negative, cosine positive is in the fourth quadrant. All right. So let's do one more. Let's do checkpoint 3, which is exactly the same thing. And maybe this time I would use the calculator to check. So I'm going to draw the axis again. Sine x, cosine x. I need to find the quadrant where sine is negative and cosine is negative. Well, sine is negative, right? This is sine. So sine is negative either here or here, right? Third or fourth because it's below the x-axis. Cosine is negative only here, right? Because it's to the left of the y-axis or here. The only place where they intersect is in the third quadrant. So the quadrant is in Q3, satisfying both those conditions. Now, let's check. I told you to pick an angle in this particular quadrant. So I'm going to pick an angle. I'm going to pick this angle right here. So this has to be an angle greater than 180 degrees. So I'm going to say, let theta be 200 degrees. And now I want to find sine of 200. And I need to confirm that this is negative. So I need to confirm this is negative. And I'm going to do cosine of 200. And I also need to confirm that this is negative, right? So I'm going to get the calculator. And hopefully this is going to work. So let's see. Do I type in sine first? No, I guess I type the angle first. So 200 sine, and I'm expecting a negative value. So sine, here is a negative. I hope you can see that. Negative 0.34. And I am going to do 200 cosine, and that should also be negative. Is negative 0.93. So both of these cases is less than zero, that checks. So the calculator is a confirmation that our work is correct. Okay. Now let's do one final example for this video. And this is a typical question on section 4.4 where we are given the a particular function of the angle theta, but not the angle itself. And we need to find, maybe we have to find, in this case, two other trig functions, but we could, have found, or we could find all other four or five. Okay, so we're given the fact that tangent is negative 2/3. Okay, and we are told that cosine is positive. So I'm going to do the graph again. Cosine is positive first and fourth. Now, the only way that tangent is negative, and remember, tangent is sine over cosine, and I already know that cosine is positive. Tangent is only negative if sine is negative, right? Because then the ratio would be negative, which means I am either in the third or fourth. So the only location where the two criteria intersect is on the fourth quadrant. So my angle is in the fourth quadrant. So I'm going to draw it here. So this is my angle. I'm going to call it theta. It's in the fourth quadrant right here. And I know that the point is, so I also know that tangent, from the definition we had before, tangent of theta is y over x. Okay? Now my point is, so the point is right here somewhere. Here's the triangle. I'm going to draw it just the triangle here. Okay. This is the y segment. This is the x segment. And here's my angle. Now, the point right here is, well, what is it? Well, it's the y coordinate and the x coordinate, but tangent is y over x. Okay? So I have 2 and I have 3. All right, so just check that. Here is my x. Here is my y. Now, it's not that the segment is negative, okay? The point is, right, negative 2 comma 3. Okay? This is x. This is y. Oops. Be careful here. Make sure I did not make any mistakes. We'll do it again. Tangent is y over x, and tangent is 2 over 3. So x is 3, right? So tangent is y over x, and it's 2 over 3. So the y segment is 2. The x segment is 3. Now, the the x segment, it has to be positive, not because it's the denominator, is because cosine is positive. So the y is negative, not because the segment is negative, but because the point is in the fourth quadrant. So don't get that confused. All right. So, Professor, why are you doing this? We know that tangent is negative 2 over 3. Yes, I know you do, but this is what we need to know, right? We need to find the other function. So I'm going to erase all of this again, and I'm going to draw this here, x. Here is my point, and this is 3. Right? This is the angle theta. And this distance here is 2, and here's the point, 3, negative 2, not 2, negative 3. Here's the point, x3, negative 2. Now, since by the Pythagorean theorem, I can find the radius. And this is why we needed to know, one, which quadrant the angle is, and then two, what is y and what is x. Okay? So here's the triangle. And now we can find r using the Pythagorean theorem. I'm going to erase this. Don't need it anymore. So the Pythagorean theorem says hypotenuse square equals 3 square, 2 square. So obviously this is 9 plus 4, 13. So take the square root of both sides. I have this. All right. So now we can find all other, all the other 5, but I'm only going to find cosine and cosecant. Okay. I could easily find cotangent. I mean, cotangent, if they asked us, is obviously 1 over tangent, so it's negative 3 over 2. So it's very easy. Now, let's find cosine. So cosine of theta is the adjacent side, 3, or x, over r. Okay? Positive 3, radius is radical 13, so we have to rationalize. So 3, radical 13, 13. And then if I wanted to, I could find secant, which is obviously radical 13 over 3. But we don't have to do that. We need to find cosecant. Cosecant. But to find cosecant, I am going to find sine, right? Sine theta, because I know that cosecant is 1 over sine. So if I find sine, I just find the reciprocal and I'm done. So sine is y over r. Now I already know that y is negative, so it's negative 2 over the radius, which is radical 13. Again, we rationalize, and we get negative 2, 13, 13. So this is sine. Now, cosecant is 1 over sine. Now, I'm not going to use this final expression. I'm going to use this because I don't have to rationalize it again. So cosecant would be 1 over negative 2, so over radical 13. So multiply by the reciprocal, we get radical 13 over 2 with a negative. Okay, so this is cosecant. So these problems from 4.4, we need to know where, which quadrant your function is in, or more specifically, which quadrant your angle is in, because that matters, which of these two values is negative, or if they're both positive. All right, so this is important. So we're going to stop here with the video, and we're going to have another video where it's going to continue this concept of where the angle is and how we can calculate other angles, regardless where they are from 0 to 360 degrees.